My name is Caroline Keats, and I am the Managing Director and CEO of ENRG Elements. ENRG Elements is an ASX-listed, African-focused exploration company. We have copper assets in the very exciting Kalahari Copper Belt in Botswana, and we have uranium assets in the uranium-rich Tim Mersoï Basin in Niger. We acquired the Agadez project in May this year, and we have undertaken a number of technical steps in order to progress this asset. I wanted to introduce you to Dave Prinsep, who is our resource geologist, who has been instrumental in assisting us with our technical program. In the first instance, Dave has assisted us review historical exploration data associated with the Agadez project. He has helped us and acted as competent person as we updated a resource from JORC 2004 to JORC 2012 compliant. And more recently, we have defined an exploration target. So, Dave, thank you very much for being here today. Could you just give the viewers a little bit of an introduction of yourself?
No problems, Caroline. Thank you very much for the introduction. I'm Dave Prinsep. I've been a geologist for over 40 years now. I graduated in 1976 from Liverpool University in the UK. I did various other things because it wasn't a great time to be a geologist in the late 70s, early 80s. Came back to geology in the early 90s and have been doing pretty much resource geology since probably mid-90s. So close to 30 years worth of resource experience, and in particular relative to Caroline's project, I've been a uranium resource geologist since the early 2000s, so approximately 20 years, estimating uranium resources pretty much all over the world. So I've got what you could say is a fair amount of experience in looking at these sorts of deposits.
And very well respected as well, Dave. So really appreciate your efforts with regards to our project, and your input has been very valuable. As you know, we have a resource at target date. Our resource is 16.5 million tonnes. We have a grade of around 295 parts per million for 10.7 million pounds of U3O8. I just wanted to ask you, how does our resource at target date compare with other similar deposits? Taking into account grade, the jurisdiction, the depth of our mineralization, and also the size of our deposit.
I think that at first sort of glance, the grade could be considered to be a little bit on the low side, but I think given the other similar sort of deposits within the area, the prospectivity within the area, it's a great starting point for your project. There's a lot of sort of exploration area that you've got, and this is the sort of first point along the journey for you with a deposit that's got plenty of room to grow. It's near surface, it daylights in some areas, it's very shallow, it would be relatively easy to mine. It's in a sort of very good jurisdiction that's got a long history of uranium mining, processing, and governance. And I think going forwards, it's going to provide significant value to your company. If you sort of look at this deposit relative to other sandstone deposits, I think the grade is definitely there. If you look at a lot of the sort of intercepts that you have, there are some significantly high values, greater than 500 up to 1,000 ppm. And it's just a matter of, I think, follow-up drilling which would expand these higher grade areas and quite possibly increase the average grade of the deposit by specific targeting of areas within the deposit. And certainly some of the work that your geologists have done following the last drilling program has identified areas which certainly warrant further investigation and will provide an updated geological model, which I think is likely to improve the deposit.
So, Dave, we talked a little bit about the fact that the deposit at Targeted is quite shallow. Now, really, our mineralisation sits within the Shirazin and the Musadin area, but there is mineralisation that is higher grade within the Carboniferous zones, and we see that in other parts of the territory in the significant deposits that are held by Global Atomic and also with the Orano mines. We also have, we've also hit mineralisation within the Carboniferous zone as well, but we haven't necessarily seen Carboniferous being so deep. You know, part of it, some of the drilling programs we've seen mineralisation within the Carboniferous zone within 50 metres of surface. Can you talk a little bit about that? Because we're likely to see more grades, you know, as we go down that type of a drilling program.
That's correct. The deposit, as it stands at the moment, is in the sort of Jurassic formations, and they are stratigraphically higher up in the sequence, and they do daylight. The Carboniferous in the area of Takadit in particular starts at about 50 metres down, between 40 and 50 metres, goes down to about 140, 150 metres, which is well within reach of reasonable cost drilling. It doesn't require expensive drilling techniques. There is a likelihood that any mining would be quite reasonable to get to these depths. Certainly looking at some of the other deposits, they are at greater depths within the same formations. They are higher grade than the current Takadit resource, but equally exploration drilling, which has been very wide spaced, it's effectively scout drilling, has intercepted significant grades at depth in the same sort of geological setting as the other mines and development projects to the north of you. So I think, you know, going forwards, whilst Takadit is a good starting point, there is definitely an attractive target in the Carboniferous mineralisation, certainly from the history north of you, and in the indications that you've already got within the drilling that you have. And I think, you know, this is it's a good project area to be in.
Yeah, I think we're pretty excited about it, and we'll talk about the future drilling program, which will probably investigate some of those other targeted areas later. But in the meantime, I wanted to go back to our current drilling program, the most recent drilling program that we completed this year, and it was about 5,500 metres of drilling. We saw mineralisation from surface down to a depth of around 40 metres, with mineralisation open in multiple directions. Our drilling was really focused for this program within and in and around that targeted resource. And as we've talked about before, you know, we saw some really nice grades, and through our downhole gamma logging, we were able to identify the most significant results of between 1,100 to 2,200. Those grades basically sit within 3 holes, and they have intercepts of around 2 metres. But one of the points I wanted to talk to you about was probably more of a technical point. If we have a look at the historical resource at Targeted, which was announced in around 2010 by NGM Resources, that was based purely on downhole logging. Now, our program of 5,500 metres had about 160 meters of diamond core. The rest of it was rotary mud. We're currently waiting on the results of the diamond core results. And once we've received that, had the opportunity to review that, hopefully we intend to, not hopefully, we intend to upgrade that targeted resource in Q1 next year. What I wanted to understand, what I wanted for the viewers to understand is how, technically, what technology are we using in order to define our resource, and does it differ, in jurisdiction, from jurisdiction to jurisdiction, as to what you can use?
It does differ to a certain extent between jurisdictions, and it's the preference for using particular techniques to get uranium values. For your projects, throughout the life of the project so far, a lot of the drilling has been mud rotary. One of the sort of two of the aspects of mud rotary is it's a relatively cheap and simple drilling process. The unfortunate downside is it does not give a particularly good sample for assaying because of the way the sample is recovered. It tends to be commingled with other intervals, so it's difficult to, from an assay point of view, say specifically exactly where grades would have come from if you do sample it. So I think particularly with mud rotary drilling techniques, people use downhole total radiometric logging or total count radiometric logging, which gives an indication of where the mineralization is. Obviously, uranium is a radioactive material. It emits through its decay chain gamma radiation, which is picked up in a radiometric logging probe. It's a scintillometer, so it detects gamma radiation. And if the probe is appropriately calibrated, you can take the counts per second from the gamma radiation that the probe receives and convert that to an equivalent uranium value, which then allows you to say where your mineralization is downhole, what the value of that mineralization is. So quite often you'll see, and particularly for your resource, there is an equivalent U3O8 value, which means it's based on downhole counts per second from a probe that's been calibrated at a standardized calibration pit. Your probes were the original work that was done by NGM. Those probes were calibrated in Saskatchewan in Canada, in the Canadian test pits at Saskatoon. And the current ones have been recalibrated at a test pit in Adelaide in Australia. These are internationally recognized calibration facilities. It generates a factor that is applied to the counts per second that the probe receives, and it will generate an equivalent uranium value. There are other factors that you may or may not need to apply to it. If it's logged in the rods, you need to know a rod factor. If it's logged in water, you've got to know the water factor. But provided you know all the appropriate factors for the logging conditions that you do, you can generate an equivalent uranium value. And for resources, and there are a number of resources around the world that are derived from downhole gamma logging, and they have an equivalent uranium value resource.
Right.
In the majority of cases, it is pretty much the same as the assay value would be. But just to let people know that it's not derived from an assay value, it's given an EU308 designation, or an EU, depending on what actual element you're discussing. At some point in the future, usually with these deposits, and you've done the same thing, you do diamond core drilling, where you get a real assay, You can send those assays off. You can get a genuine uranium value for it. And then you compare the uranium values that you have for your diamond core against the gamma values for the same drill hole. And you can come up with a genuine equivalence between a gamma-derived value and an assay value. And then that allows you to convert your resource to a standalone uranium value resource.
Okay. Okay. So, and in some jurisdictions, they don't use gamma logging too much in order to determine their resource. I'm in places like Canada in the Athabasca Basin. Can you explain why that would be?
There are certainly sort of historical preferences. The downhole gamma using scintillometry is really the sort of province of what you would term lower grade deposits, because of certain restrictions in the physics of downhole gamma probes. You can swamp them. If the mineralization is too strong, it can effectively swamp the scintillometer, or even if you go to a less sensitive Geiger-Müller tube, they can still be swamped by the amount of gamma radiation that they're presented with. When that happens, you lose counts. There is a factor that is applied to the probes that are used on lower grade deposits called dead time. And that's the amount of time that the system can't read values coming into it. So for very high grade deposits, dead time becomes a very significant amount. Additionally, a lot of those deposits are subject to diamond drilling, where you get a decent sample anyway. And I think for a combination of issues with downhole radiometric probing in high-grade environments and the fact that you have a good quality sample to start off with, there has always been a preference to go for assays over equivalent uranium values. But ultimately, there is no reason, if you know all the factors that are going to affect your downhole gamma values, counts per second values, why you couldn't use downhole gamma for deriving a value for a resource.
And throughout Africa, would you say that most of the deposits use gamma radiation, in order to, I suppose, define their resource, or do the majority of the work in defining the resource?
The vast majority do. There are a number of hard rock deposits which have variable amounts of thorium in, which can affect the counts that you get in a downhole gamma total count gamma probe. But for example, all of the Namibian deposits, the calcrete deposits in Namibia, would be run using total count downhole radiometric probes. Rossing wasn't, because there is a variable thorium issue, because you're dealing with granites, some of the sort of hard rock mines there. But the vast majority of what would be termed clean uranium deposits, sandstone uranium deposits, are run with downhole total count radiometric probes.
Okay, thank you for that. Can we talk a little bit about our exploration target? So recently, we announced an exploration target at Agadez of between 90 to 130 million pounds of U3O8. We're looking at average grades of between 300 and 400 parts per million, with an average mineralization thickness of between 2 and 5 meters. Could you just explain to the viewers what process we used, or you used, in order to define that exploration target?
Yep. The exploration target was based on all of the historical drilling. So not only did NGM do drilling throughout the 3 tenements that you have, Paladin, as the sort of previous major owner, did about 11,500 meters worth of drilling throughout those tenements as well, targeting.
Sorry, Dave, it was 6,500
Okay.
based on the tenements that we acquired.
Yeah. So that was targeting deeper carboniferous mineralization. So the sort of like mineralization to a number of the deposits to the north of the tenements that that you have, and looking at the grades, the thicknesses, the locations, in conjunction with a number of historic Kojima, now Orano, holes throughout the area, suggests that there is significant mineralization available to you within that area. And that's where the sort of exploration target was generated from. It's based on grades, thicknesses, and distribution of existing drilling.
Yeah. So at the same time that we announced the exploration target, we also announced a drill program in the order of around 20,000 meters for 379 holes with an average depth of around 50 meters. Now, we intend on implementing that drill program in phases. What does that drill program, for the benefit of the viewers, do with regards to our exploration target?
It's a stepping stone along the way. You have currently an exploration target, which has a sort of an expectation, if you like, of where you are trying to get to. And the drilling program is a step along the way to that. It's to confirm particular areas or confirm mineralization in particular areas. And it's to more focus future exploration efforts onto specific areas. So the program, as it's designed at the moment, will follow up on some of the existing drilling, particularly some of the structural controls that we believe are controlling mineralization along with the particular stratigraphies that we're looking at. And it's designed to be a step along the way to confirming mineralization, and then at some point in the future, follow-up drilling for resource definition work. But that's probably a reasonable distance down the track.
So we're a little bit excited about the whole process and looking forward to implementing and advancing the project. Thank you so much for your help and your assistance, and thank you for making yourself available for this video now.
No worries at all. It's been a great journey so far, and I'm looking forward to the future.
Thank you so much, Dave.